Hello, today I'm going over Atomic Models lecture. So we've seen this model of the atom before, pretty common for our introductory textbooks and activities around learning the structure of the atom. So this is the Bohr model. The Bohr model of the atom was proposed by Niels Bohr in 1913 to explain the structure of hydrogen. In this model, electrons moved in fixed circular orbits around the nucleus, similar to planets orbiting the sun. That's what we see here, a couple of electrons on this orbital, and then two more on the next one, two more on the next one. So a classic model that we still use to introduce the atom. Each orbit has a specific energy, and electrons cannot exist between these allowed levels. So there is no partial orbit between one orbit and another. There's nothing in this space, just an orbital here and an orbital there. When an electron jumps between orbitals, it absorbs or emits energy in the form of light. So an electron can absorb energy coming in here, and it can jump up to a higher orbital here. And if it goes back down, it will also emit that same energy out, or it will emit some energy out as light. Energy levels in an atom refer to the specific energies that electrons can have while bound to the nucleus. So we have already seen these orbitals, but now we're thinking of them as different energy levels. These levels are quantized, meaning only certain discrete values are allowed rather than a continuous range. Again, there's no little orbits in here between energy level 1 and 2. It's not a continual progression. It's energy level 1 or energy level 2. Electrons in lower energy levels are close to the nucleus and are more stable. So more stable in here, less stable out there. When electrons move to higher levels, they require an input of energy, and when they fall back down, they release energy, just like we talked about up here, okay? All right. The concept of quantum refers to the smallest discrete amount of energy that can be gained or lost by an atom. So when we're referring to this energy gained or lost, again, it's a specific amount. It's not continuous. It's either this amount of energy or this amount of energy. There's no in-between packet of energy. This idea was crucial to explaining why atomic spectra show distinct lines instead of a continuous spread of colors. Energy changes occur in fixed amounts, not gradually, which challenged earlier classical physics ideas. So again, we're learning more and more the more evidence we collect. And again, it's just this idea of the orbitals have specific energy levels. To bump up to a different orbital requires a very specific amount of energy. It's not this accumulation of energy. This quantization is a fundamental principle that underlies modern atomic theory. The quantum mechanical model replaced the Bohr model by providing a more accurate description of electron behavior. So now this is taking into account quantum physics, which Niels Bohr was certainly largely responsible for. But our understanding has grown, and even though we talk about orbits still, really we're saying there's a possibility of places that the electron will be found. It is in none of those places until we look to see where it's at. It's just a probability of where it'll be at. That's when you get into quantum physics and it gets weird. Let's see here. Instead of fixed orbits, electrons are described by wave functions that give the probability of finding an electron in a certain region. This model is based on complex mathematics and incorporates principles like wave-particle duality and uncertainty. This is getting complex, so that's a later idea, basically. It explains not only hydrogen, but also more complex atoms. So these electron clouds, where you would possibly find the electron. So back to orbitals here. Atomic orbitals are regions around the nucleus where electrons are most likely to be found, and they are identified by letter abbreviations such as S, P, D, and F. So we're talking about orbitals, but we're also talking about clouds or shells here of where you're likely to find the electrons. And we're going to get some weird shapes of where you're going to find these based on different energy levels. The s orbital is the simplest shape, forming a sphere centered on the nucleus. That's this one. So this is an s orbital, just a sphere centered on the nucleus. And it increases in size as the energy level, principal quantum number, increases. So there's a few s orbitals, and the sphere will get bigger. Okay. The p orbitals here have a dumbbell shape with two lobes extending along specific axes. So it could be the z-axis like here, or the y-axis, or the x-axis. And they are larger and higher in energy than the s orbital in the same energy level. So more energy here than in the s orbital. These get weird shapes because now we're getting electrons interfering with electrons, repelling other electrons. So you get some unusual patterns as there's this interaction. These differences in shape and size influence how electrons are distributed in an atom. And then down here, basically, it just gets more complex because the atoms are going to get bigger, they're going to have more electrons, and you're going to get all kinds of weird shapes to the orbitals, or areas that you're likely to find the electron. The d and f orbitals are more complex in both shape and size, with d orbitals often appearing as four-lobed clover shapes, and one having a donut-shaped ring around the center. That's what we see here. Again, you get these four lobes, these clover leaf, or this one here with spheres and a donut, based on interactions with other electrons. The f orbitals are even more intricate, with multiple lobes that make their shapes harder to visualize. That's down here. Again, more and more electrons, more and more unusual patterns. As you move from s to f orbitals, the orbitals generally become larger, higher in energy, and more complex in structure. Each type of orbital also exists in different orientations and extra levels, which further affects the overall size and arrangement of the electron cloud. Okay, so this is just getting us started on this kind of stuff. It's an introduction. So if you have any more questions about this, let me know. Hope this helps. Thank you.